So normally what you do is you try to develop a model first on a large data, build a model on these features, then you use this as a pre-trained model for a new task. So the develop model approach here is primarily meant for when you are developing a large architecture for potential reuse by a lot of new people without them having to develop from scratch. You should develop this problem on a huge data like ImageNet or maybe CIFAR10 data. The idea is the more realistic set of examples you let your data work on, you can use that to be reused for different later problems with the pre-trained approach. Then one thing I'll again want to mention here, while I've been stressing a lot on ImageNet and the concept of large ImageNet based reusable large neural network models, but let me tell you, this is not restricted to image. The transfer learning approach works with text data also, or with speech data also. So for example, I'll give you an example in the text domain. Just like we have ImageNet as a ground truth for a lot of image classes, similarly in the text domain, we have already seen the concept of word embeddings, which is basically responsible for most of the word related problems in text, whether it is clustering, whether it is classification, or whether it is information extraction from text. But in all of these cases, we know that the better way is to develop a customized word embedding for your domain and use that for developing your classifier or regressor, etc. But let me tell you, even there, if you're assured that you have a large corpus of text on which, suppose you've developed a large word embedding, it is possible to reuse the same thing in several smaller text classification models using the large predefined model. So just like we have ImageNet based large predefined pre-trained models of neural network architectures for images, we have word embeddings for large text corpus like Google News Vectors, for example. Google News Vectors is a large collection of news articles from the internet on which there is a large corpus developed of word embeddings, which you can reuse and do transfer learning in the text context. Similarly, recently there's been a lot of work by Google by collecting a lot of real world utterances, and they have created a ultra large model of embeddings for the chatbot, open-ended chatbot called Veena. So the idea of what I'm saying here is when you develop the model on huge data, it's not that it is only for images, it can be for large text corpus also. So today you have large text corpuses, large image corpuses, but we will study a little bit more in depth of some of the large image corpuses and then see a practical example of how you can use the pre-trained model for your own application in context of images. So what the pre-trained model approach does is, suppose you have a large pre-trained model. For example, you have something like, say, AlexNet, which was the network used by Benzio and Hinton, etc., for winning the ILV SRC challenge and increasing the percentage from 70s to 80s. AlexNet is one of the large pre-trained models, which is considered as one of the pioneering architectures of pre-trained models. Similarly, there are many more such variants which are coming up. As we speak, we are talking about pre-trained models, which are tens of layers. So what happens with this pre-trained model is that if the data on which you want to do image classification is not very different from usual classes which are already captured by ImageNet, then AlexNet can be used for similar problems. So any model which is trained on such large data can be used for image classification in the new problem. And the idea is, it's not that the whole model need to be used. You can basically choose, suppose you have a 20-layer model of AlexNet. You may choose all the 20 layers, and the final layer is where you want to strip off. Basically, the output is different. And you may add to that your current input data to be trained on and get one layer on top of it and create a classifier. So in that sense, you're using all the network layers except the output layer from the AlexNet. Or you can say, I want to choose only up to 10 layers and then kind of construct the higher layers from my data. So the idea is, the developed model, how much of the previous data based trained model, which is the pre-trained model you want to use, depends upon your choice. At what layer you want to cut off, and then you at what layer you want to append your custom training to be done. So let me pause here and tell you what is the rationale behind it. The rationale behind it is very simple. If you remember the hierarchy of features which were shown visually in deep learning, if at the lowermost layer, just above images, what we find is they capture very fine-grained features in the images, like what are the small curves. Then we see slightly more edges on top of it as the next layer. Then maybe collection of edges which may form a body part, or it may form a character, etc. in the higher. So as we go higher and higher, you see features which are closer to the target data which you are considering is getting specifically captured, whereas generic features are captured in the lower layers. So it is possible that in your domain, the overall objects are quite different from the classes of images captured in ImageNet, but that does not prevent you from reusing the core edge and basic, curve features extracted from any general images to be captured from AlexNet. So you may say, up to 10th layer, I'll use AlexNet. From that, beyond that, I will train them on my current model, on current data, with adding 2 or 3 more layers of CNNs. So you need to understand that this is again a developer or designer's choice in terms of where you will cut off the pre-trained model, how much of pre-trained model you will reuse, and how much of customization you will do for your target domain. We'll also show that in the program, where we're actually showing an example where we'll do the complete reuse of all the layers except the last layer, which will be based on our custom data.